In this video, we're going to go beyond the basics with properties of functions and linear models, section 2.1. We're going to start with an applied problem. Let's read this. It says, suppose that a company just purchased some new office equipment at a cost of $2,500 per machine. The company chooses to depreciate each machine using a straight line method over 5 years. Straight line means we're going to get a linear equation here for the model. This means that each piece of equipment will depreciate at $2,500 divided by 5, or $500. 500 represents our rate of change, right? But it is depreciating. Depreciating means losing value. So we can get from this that we are losing value at $500 a year. So our slope or rate of change will be negative 500. Our starting value, B, is 2,500. It looks like we have enough information here to make a model, and that's what we're going to do. Part A says to build a linear model that expresses the value, V, of each machine as a function of X. So we're finding V of X. Lucky us, we already know our rate of change and our y-intercept, and we have our model f of x equals mx plus b to follow. M is our slope, b is our y-intercept. And we can just fill in negative 500 x for years, and then plus 2,500, our starting value. We are asked, what is the implied domain of this function found in part A? Well, when we're talking about the domain, we're talking about the x value, and the x value is the age. Well, the age isn't going to be less than 0 because that's when it's brand new. So I'd say the starting value here would be at 0. And we're told that the straight line method is used over 5 years. So we're only looking in a time period of 0 to 5 years. In interval notation, that's bracket 0, comma 5, bracket. Next, we are asked to graph this function. So we can just sketch a graph here. We have our x-axis, which represents age, and our y-axis, or our v of x axis, is the value, and that's in dollars. And we can use our function listed to get our y-intercept, 2,500. So let's note that on our graph. 2,500, I'm just doing a rough sketch here. And we can also find what our 0 is. So our 0 is going to happen when v of x is equal to 0. So we have negative 500x plus 2,500. I can subtract 2,500 from each side of my equation, and I'll get negative 2,500 is equal to negative 500x. And I can divide both sides of my equation by negative 500. And I'll get x equals 5. So I have the point 5, 0. And I have a line going between there. That's a quick graph of my function. And we're asked, what is the value of the machine after 2 years? Let's find f of 2. Well, we can put into our function negative 500 times 2 plus 2,500. And when we calculate that, that would be $1,500. We are also finally asked to interpret the slope. The slope, m, is negative 500. So we can say that the machine, or each machine, loses $500 in value per year. We are also asked when will the value of each machine be 500. So it's asking when is v of x equal to 500? Well, let's take our equation, negative 500x plus 2,500, and go ahead and solve for x. We'll subtract 2,500 from each side, and we'll get negative 2,000 equals negative 500x, and divide each side by negative 500. And from there, I'll get x is equal to 4. So after 4 years, each machine will be worth just $500. The next kind of problem that we're going to do is the equilibrium problem. Suppose the quantity supplied, S, and the quantity demanded, D, of t-shirts at a concert are given by the following functions where P is the price. S of P is negative 280 plus 40p, and D of P is 800 minus 50p. So the supply, S, is the amount of your product or good that a company or supplier is willing to provide, whereas demand, D, is the amount of the quantity or good that the consumer is willing to purchase. So to find the equilibrium price of the t-shirt, as we are asked to do right here, the equilibrium price is where the supply meets the demand. So essentially, supply is equal to demand. We set our equations equal to each other. So I know that supply is negative 280 plus 40p. So in the equation I just wrote here, I'm going to substitute negative 280 plus 40p, where it said supply. I know that demand is 800 minus 50p. So I'm going to take my 800 minus 50p and substitute on the right side, 800 minus 50p. Now I have one equation with one unknown, and I can solve for my unknown. So I am going to get all of the variable on one side by adding 50p to each side of my equation. Negative 280 plus 90p equals 800. Now I will subtract, or I should say, subtract negative 280, or just add 280 to each side of my equation. And I'll have 90p is equal to 1,080. When I divide both sides by 90, I'll get my equilibrium value. And I get 12. The price should be $12 per shirt to have that equilibrium where supply meets demand. Next, I'm asked to find the equilibrium quantity. To do that, you simply plug in 12 for P in one of the equations. So I'm going to find S of 12. And that's negative 280 plus 40 times 12. When I do that, I get 200 t-shirts. That's the equilibrium quantity. Lastly, for this problem, we need to find out when the prices for quantity demanded are greater than the quantity supplied. So we're finding out when D of P is greater than S of P. So we are going to take the equations and set up an inequality and solve said inequality. So I'm looking at my equations, and I can say that D of P is 800 minus 50p is greater than negative 280 plus 40p. I can zoom back in. All right, so I'm going to once again get all of the p's on one side and all of the just plain numbers on the other side. So I'll add 50p to each side. I'll get 800 is greater than negative 280 plus 90p. And then I will add 280 to each side. And I'll get 1080 is greater than 90p. When I divide each side by 90, I'll get P is less than 12. So P is less than 12. But when we think about this, we can't sell a negative amount of t-shirts. So that means P also has to be greater than or equal to 0. So when I put that together, we get P goes from 0 to 12. You can say bracket 0 to 12 if you want to, either of these answers. So we can say that the prices for which the quantity demand is greater than the quantity supplied is when P is greater than or equal to 0, but less than 12. Our last order of business is to explore graphs and compare functions looking at those graphs. We have, first thing we're going to do is we're going to find when f of x is equal to g of x on this graph. You see we have h of x, we have f of x, and we have g of x. H of x and g of x appear to be parallel lines, while f of x is a diagonal that goes through them. So we want to find where f of x is equal to g of x, and that happens to be where these functions intersect. So f of x is equal to g of x where they intersect, and we have the point -4, -3, but only one of those represents our answer. And if you think, if we were solving a linear equation as we did in the last problem, the answer was always the x value. So f of x equals g of x at x equals -4. That'll be our answer. Now we're going to solve the inequality. G of x is less than or equal to f of x is less than h of x. So f of x is greater than or equal to g of x, but f of x is less than h of x. So first thing we're going to look at is where is f of x greater than or equal to g of x. So I'm looking at my f of x and I'm seeing what y values, what outputs of f of x are greater than or equal to g of x. And I'm going to highlight that. So the output or the line is of f of x is above the g of x line in this whole area here. And that starts at x is -4. So I know that whatever my answer is going to start with -4. Now I need to find out where is f of x less than h of x. F of x is less than, so the line for f of x is under the h of x line in all of these highlighted areas in red. And because it's just a less than sign, the part where they intersect is going to be an open circle. The x value associated with that open circle is 3. So I have 3 here. So my answer for part B is going to be bracket -4, comma 3, parentheses. Let's try another. Solve the inequality. G of x is greater than h of x. So h of x is right up here. G of x is down there. And g of x will be greater than h of x where its line is above h of x. I don't see any areas where that happens. So we're going to say that there's no solution to that inequality. It never happens. How about where is g of x equal to h of x? There's no solution to that too. How do I know there's no solution? These lines are parallel. They never touch each other. They never intersect, so they will not have a solution. One last example. When is f of x greater than 6? So that means when is the output of the function or the y value greater than 6? And I'm looking at my f of x function right here. Highlight it. And I'm looking for when it has an output greater than 6. And I can see the output is 6 right here. Where does that happen? It happens at the number 3 and anything later than 3. So I can say my answer, f of x is greater than 6 when x is greater than, should have an open circle here, sorry, than 3. or we can say 3 to infinity.